parts problem. So in this problem, this strut that goes into your car as a shock absorber. So basically this acts as a column. So as you can see, we can think of the whole thing as a column. Also we can think of this, just this, the rod, that part is just sticking out of the piece cylinder. We can also think that as a column. So in column design, it says that design this column. So we have to kind of make an assumption whether it's a short column or intermediate column, because the formulas are different. Let's assume that this is an intermediate column. If it's an intermediate column, then the formula that is used to calculate that is the allowable stress times the force, the factor of safety, divided by the yield distance of the material, is equal to 1 minus the yield distance of the material times KL by R whole square divided by 4 pi square E. Now from this problem, it says 4,000 pound load is applied, so we can calculate the stress. FA is the force divided by the area, pi by 4 d square. So now we can plug all this number here. So FA, we can replace that with 4,000 pounds. Everything is in KSI, so let's make it, instead of just 1,000 pounds, let's write that 4 kips. So 4.0 kips maybe, then this thing will come basically 4 by pi by 4 d square. So the unit would be KSI, like that. So 4 KSI divided by pi by 4 d square, that's FA, times the factor of safety. Typically factor of safety for machine parts is 3, divided by this yield distance. For stainless steel, let's assume this is designed by stainless steel material, so that's 40 KSI yield strength for stainless steel, equal to minus 40 KSI again. Now K is the value this is a constant. It comes from how these ends are connected. So in this case there could be 4 possible connections. Check the introductory video on columns, how to define what kind of connection is this thing. This is a fixed connection. This is fixed to the bearing plate, and then this side is fixed by the cylinder wall. So this is a fixed connection both sides. For that, the K value is 0.65 times the length of this column is 14 inches. I'll keep it in 14 inches. Now for a circular section, R is d by 4, so I can just put here d by 4 and then whole square all of this, divided by 4 times pi square times the modulus of elasticity for steel, which is 29,000 KSI. Now if I can solve for, let's do it part by part. So on the left side I got 0.382 d square is equal to, on the right side I got this 0.046 d square. So I can calculate the solve for d. So I found 0.4283 by d square is equal to 1. So d, I have found that 0.654 inches. So that's the diameter of this piece. Now we have assumed that this is an intermediate column, intermediate or short column, the same thing. Now we're going to verify whether our assumption was correct or not. So you have to calculate the KL by R. So in this case K is 0.65 times L is 14 inches divided by R is d by 4, so 0.654 divided by 4. So I have calculated this piece 55.67. So that's the KL by R value. We have to compare this value with this value, which is the material property. So pi square E divided by, so this comes from the material property, yield strength. So if I plug all these numbers, I get square root of 2 pi squared times 29,000 ksi divided by 40 ksi. So I have found this value 119.6. So in this case we can see that KL by R is smaller than the square root of pi 2 pi square E by Fy. So if this is KL by R is smaller than this value, then it's a intermediate or short column. So our assumption was okay. So the final column diameter would be 0.654.